Welcome everybody. So starting off with section 1.5, we're going to look at solving linear equations, which is by far the most important skill that we learn in this class. Much of what we do in this class will depend on your ability to solve linear equations. So first of all, what is a linear equation? A linear equation is an equation that has the form ax plus b equals c, where a, b, and c are numbers, and the number a cannot be 0, and x is our variable in the equation. And if you have a true linear equation, it will only have one answer. And our primary task here is to talk about how to solve these linear equations. And this is mostly a review topic. I understand some of you might be a little rusty when it comes to solving equations, but we will hit on most of the important skills as we do examples. So let's go ahead and get started. So in our first example, we have 4x minus 7 is equal to 5. And you'll notice that this exactly fits this format. Now, what we want to know is what is the value of x that makes this equation true? And for some of these initial examples, you might even be able to solve these equations without doing any work. But we always want to make sure that we show all of our steps when we're solving problems. So what we can do to isolate x, to get x all by itself, is we can add 7 to both sides. This is the addition property of equality. And by adding 7 to both sides, basically what that allows us to do here is cancel, because negative 7 plus 7 equals 0. Now once we do that, on the left-hand side, all we have left is 4x. And on the right-hand side, 5 plus 7 is 12. Now from here, to get x by itself, we need to eliminate the 4. And since we're multiplying x by 4, to cancel that, we need to divide both sides by 4. And when we divide, 4 divided by 4 cancels out. And so on the left-hand side, we have x. And on the right-hand side, 12 divided by 4 is 3. So we think x equals 3 is our answer. And I won't do this for every problem, but I want to remind you that anytime you solve an equation, you can check your answer. And so if we want to check to see if x equals 3 is actually a solution, what we need to do is take the number 3 and plug it into the original equation. When we do that, we get 4 times 3 minus 7 equals 5, and I like to put a question mark there because I'm checking to see if indeed that is true. Well, 4 times 3 is 12, and so this says 12 minus 7 is 5, and that of course is true because on the left-hand side we get 5, and on the right-hand side we also get 5. Now, when doing homework online, you don't always have to check your answer. Most of you will simply plug it into the computer and hit enter, and it will let you know if your answer is right or wrong, but you should know at least how to check answers by hand. Okay, so for our next example, it's very similar. To solve for x in this equation, we're going to start by subtracting 3 from both sides so that we can get rid of the plus 3 that's there. When we do that, we end up getting x over 4 equals negative 6 minus 3 is negative 9. And then we have x divided by 4, and to get rid of the 4 here, we need to multiply both sides by 4, which is the same as multiplying by 4 over 1, if you prefer to write it in that way. After doing that, the 4's cancel, and we end up getting x equals negative 9 times 4 is negative 36. And I won't bother checking every answer, but feel free to check anytime you would like to. In example 3, it's pretty much the same type of equation, but I've put a couple of decimals in the problem. Please understand that you still do the problem the same way. So to get x by itself, I'm going to subtract 0.5 from both sides. This will cancel positive 0.5 and negative 0.5. And on the left-hand side, we're left with negative 2x is equal to 1.9 minus 0.5 is 1.4. And then to cancel the negative 2, when dividing, you have to divide by exactly the same number, not the opposite. So negative 2 divided by negative 2 cancels out, and we end up getting x is equal to 1.4 divided by negative 0.2. And this is a good time to tell you that you can use a scientific calculator in this class. So you can do this on a calculator or you can do it by hand. But I know that a positive divided by a negative is always a negative. And 1.4 divided by 2 is 0.7. All right, let's move on to the next page. So in our next example, it's actually very similar to one that we did on the previous page, with one minor modification. So here we want to solve for t. Notice the variable has changed to a t. It doesn't matter what letter we use for the variable. So we'll solve it the same way. I'm going to add 10 to both sides. And this will give us cancellation here. And then we have negative 3/4 times t is equal to 33. Now the key point to make is that when a variable is multiplied by a fraction, the way you get rid of that fraction shouldn't be by dividing by a fraction. Dividing by a fraction can be problematic, especially when doing these without a calculator. So what we want to do here is multiply both sides by the reciprocal of negative 3/4. And the reciprocal of negative 3/4 is negative 4/3. What this does is cancels 3 and 3, 4 and 4, and the two negatives become a positive, and all we have left there is a t. And then on the other side, it's useful to go ahead and express 33 as 33 over 1, and then we can cancel in the same way. 3 goes into 33 11 times, and 11 times negative 4 is negative 44. And in the denominator, all we have left here is a 1 here and a 1 here, and 1 times 1 is 1. And so we don't need to write that. So our answer is just t equals negative 44. Also, I think this is a good time to mention that if ever you feel like I'm going too fast in these problems, since you're watching this on YouTube, you can, of course, pause the video at any time. And I actually really recommend that you try to pause the video and take accurate notes. So one advantage to doing this online and watching a video is that you truly can go at your own pace. So in our next example, notice that it's a little bit different because we have variables on both sides of the equation. Now, when you have variables on both sides, what you want to do is get all your variables to one side of the equation. You don't have to do that first, but I personally think it's best to get all variables to one side of the equation first. So I have two options. I could either subtract 5x to cancel these, or I can add 7x to cancel these. I'm going to choose to add 7x to both sides. And notice that when I add 7x, I'm making sure that I line it up with the other x term, because you have to combine like terms. Now, why did I add 7x? Was it to get the x's on the left-hand side? I know that many of you probably prefer to have your variable on the left-hand side, but that's actually not why I did it. I did it because I prefer my variable to have a positive coefficient. And by adding 7x to both sides, that gives us 12x, which is positive. And then the minus 10 comes down. And on the other side, we have cancellation here. And the positive 19 comes down. Now from this point, it's pretty much like the rest of the problems that we've been doing. So I'm going to add 10 to both sides now. That gives us 12x equals 29. And finally, I'm going to divide by 12, which cancels nicely, of course, on the left-hand side. And our answer is 29 divided by 12. So how should we write that answer? It does not reduce, and actually, there's nothing wrong with that answer. You should just leave it as 29 divided by 12. It's not necessary to plug that into a calculator. If you do plug it into a calculator, you're going to get a decimal, and that decimal would need to be approximated. So just for clarity here, 29 divided by 12 on a calculator is 2.41666667. This is an approximation. It's actually 2.4166666 forever sixes. So this is why we don't like to give a decimal answer unless we're specifically asked to do so. Because anytime you give a decimal answer, you run the risk of approximating that answer. And if what they want is an exact answer, then 29 over 12 is the way to write it. Now, just to say one more thing there, sometimes you'll be asked to approximate your answers to a certain number of decimal places. For example, you might approximate it to 2 decimal places. And if that's the case, you would cut it off right there, and this would become 29 over 12 is approximately equal to 2.42. But again, this is not exact. So to try to keep a long story short here, just give the fraction answer unless you're specifically asked for a decimal. So our next example also has variables on both sides of the equation, and for the first time we have some parentheses involved. When you have parentheses in an equation, most of the time you want to multiply out those parentheses. So that means we need to use the distributive property to multiply negative 2 by both x and 4. So we know negative 2 times x is negative 2x, and negative 2 times positive 4 is negative 8. And the rest is the same. Plus 5 equals 3x minus 8. The next step that I would like to do here is simply combine like terms. So on the left-hand side, notice that we have negative 8 and positive 5, which combines to make negative 3. Now this problem is very much like our last example, and we have to make a choice as to which side of the equation do we want to put the x variable on. So I can either subtract 3x or I can add 2x. And for this problem, I'm going to add 2x. Now again, to be clear, you can do either one and you should end up with the right answer either way. But the reason I prefer to do this is after the cancellation here, we end up getting negative 3 equals positive 5x minus 8. So again, Me personally, I prefer to keep the coefficient of my variable positive if I can easily do so. After this, we add 8 to both sides, and that is going to give us positive 5 equals 5x. And finally, we divide both sides by 5, and that gives us 1 is equal to x. And that's our answer. And it doesn't matter if our answer is 1 equals x or x equals 1. It's the same thing either way. So next up, we have a problem involving parentheses, but also involving fractions. And there's a number of fractions in this problem. You can see that we have 3 fractions, and they all have a different denominator. There are a couple of different ways you can approach solving this problem. But I think the best way to do it is to get rid of the fractions first. So what we need to do is identify the least common denominator of 3, 4, and 12. And that least common denominator is, in fact, 12. Then what I'm going to do is multiply both sides of the equation by 12. So we're going to multiply this term by 12, this term by 12, and also this term by 12. And so when we do that, we get the following. And when we multiply by 12, for some of you it might be convenient to remind yourself that this is 12 over 1. And what you're doing is you're looking to cancel denominators. So for example, here in the first one, 3 goes into 12 4 times. And so what we have left over there is 4 times 2, which is 8, and then times a plus 3. And we'll multiply out those parentheses in the next step. On the other side of the equation, 4 goes into 12 3 times, and 3 times 5a is 15a. And finally, 12 cancels 12 out completely here, and we get 17. Once those fractions are removed, this becomes a relatively simple example, very much like the other problems that we've done in this section. And so to finish this up, I'm going to subtract 8a from both sides, and simultaneously, I'm going to subtract 17 from both sides. Now, you don't have to do more than one step at a time if you don't want to. I'm just showing you that it is an option. And finally, I'm going to divide both sides by 7, and we once again get 1 for our answer, which is a coincidence, of course. So our next example is actually very similar to the last problem. We have multiple fractions here. And so I'm going to identify the least common denominator, which in this case is 30. 30 is the smallest number that 2, 5, and 3 will all divide into evenly. So now we're going to multiply both sides of the equation by 30, which means every term gets multiplied by 30. So when we make that step, we get the following. And remember, the whole point of multiplying by the least common denominator is that you'll be able to do a lot of cross-canceling. So here, 2 goes into 30 15 times. Here, 5 goes into 30 6 times. Here, nothing cancels. And here, 3 goes into 30 10 times. Doing the math, we have 15 times 5 minus m, minus 6 times 3m is 18m, equals 30 times 2 is 60, plus 10 times m plus 1. Then we need to multiply out the parentheses. So again, if I'm going too fast, pause the video and double check for yourself that this is correct. Next, we combine like terms. So negative 15m minus 18m is negative 33m. And on the other side, we have 10m plus 60 plus 10 is 70. And then I'm going to add 33m to both sides. And as you can see, I'm running out of room here. So I'm going to bring this answer up here. Well, it's not the answer, but the next step. That gives us 75 is equal to 43m plus 70. And then if I subtract 70 from both sides, this will give us 5 equals 43m. And our last step is to divide both sides by 43. And that gives us m equals 5 over 43. And this is how you should leave your answer. Now our last two examples are special examples. Now when you look at them, I hope you notice that you can't tell if they're special just by looking at them. It's when you start doing the problem that you'll notice that something different happens. So in number 9, I'm going to multiply out the parentheses, which gives us 5x plus 5 minus 6 equals 5x plus 14. Combine like terms here, and that gives us 5x minus 1 equals 5x plus 14. And you might start to suspect that something different is going on here because we have the same number of x's on both sides of the equation. So if we subtract 5x from both sides, notice that the variable completely cancels out and we get negative 1 equals 14, which of course is not true. So because this is not true, that means there is no solution to this problem. Problem number 10 is very similar. So we multiply out the parentheses here and on the other side as well. Combine like terms on the left-hand side and we get negative 5x minus 6. Combine like terms on the right-hand side and we get negative 5x minus 6. And so the same type of thing is happening here as what happened in the last problem. If we add 5x to both sides, we end up, once again, canceling the variables. But this time, we get a true statement. Negative 6 is equal to negative 6. So what this means is that any number will be a solution for x. That means the solution is all real numbers. Now technically, these last two examples here, these are not linear equations technically, because what happens when you cancel the x's is you get 0x. And remember in the beginning when I said the number in front of x can never be 0 when you have a linear equation? So technically these are not linear equations, which is why you don't get one single answer for your variable. These are two special cases, but you need to be aware that this can happen. All right, so that concludes 1.5, but we are going to move right into 1.6. 1.6 is a section on solving formulas, and it really goes well with section 1.5. So first of all, what is a formula? Well, a formula is an equation that has two or more variables. So all the equations that we solved in section 1.5 were not formulas because each equation only had one variable. So let's start with some examples of formulas. And you'll recognize some of these. First formula, P equals 2W plus 2L. This is an equation that has three variables, P, W, and L. And actually, if you remember from geometry, this is a formula that gives you the perimeter of a rectangle if you know its width is W and its length is L. And the perimeter, of course, is the distance around the rectangle. Second example of a formula, I equals P times R times T. This is a formula about interest. When you put money in the bank, you earn interest. And this equation, of course, has four different variables, but you can't really draw a picture of it. This is more conceptual than anything else. Next formula, D equals RT. This is a formula that distance equals rate times time. And again, it's kind of difficult to draw a picture of this formula. It has to do with things moving and covering distances in amounts of time. But we will talk about both of these formulas later in the course. The next formula is 5x minus 4y equals 20. And I want you to notice that it does fit the definition of being a formula because it has more than one variable in that equation. But it's not a formula that represents anything necessarily in the real world. So a formula doesn't have to be something that represents a known situation in the real world. It could just be an abstract equation involving a couple of variables. And our last example of a formula, pretty complicated one, S equals N over 2 times the quantity 2A plus the quantity N minus 1 times D. And this is the formula for finding the sum of an arithmetic series, which you don't need to know what this formula is used for right now, but notice that it is a formula that has four variables. We have an S, N, A, and D. So what we want to be able to do, in addition to just use formulas by plugging numbers into them, is we want to be able to solve formulas for a particular variable. So let's have a look at some examples of doing that. So in our first example, we have the formula for the perimeter of a rectangle, and it's currently solved for the variable P. I want to solve it for the variable L. So the way we do this is very similar to solving an equation. If I want to solve for L, that means I need to get L by itself. So I'm going to subtract 2W from both sides. And that gives us P minus 2W is equal to 2L. And then to get L completely by itself, I need to divide the right-hand side by 2, which means I must also divide the left-hand side by 2. These cancel. And when solving a formula, you should always write your variable that you're solving for on the left-hand side when you're finished. So I'm going to move the L to the left-hand side, and on the right-hand side we have P minus 2W all divided by 2. And this is the answer. Please do not cancel these 2's here. You cannot do that. You can only cancel if both terms have a 2. So just leave the answer as is. In our second example, we have I equals PRT. And if we want to solve for T, notice that all we need to do is cancel the p and the r on the right-hand side. And since everything on the right-hand side is being multiplied to t, we can simply divide by PR on both sides. And this will give us I over PR is equal to t. And so again, that's the answer, but get in the habit of writing your formula with the variable that you want to solve for on the left-hand side. Third example, here we want to solve for y. So to do that, we are going to first subtract 5x from both sides. Doing that will give us cancellation here. And we get negative 4y equals 20 minus 5x. And then the next step is we need to divide both sides by negative 4 to get y by itself. Now, what I like to do here is divide each of these separately. And if you do that, 20 divided by negative 4 is negative 5. And then negative 5 divided by negative 4, the negatives cancel, and we get positive 5/4 x. And so our final answer here, we can actually write in two different ways. We can write it as y equals negative 5 plus 5/4 x, or we can say y equals 5/4 x minus 5. Again, both of these are acceptable, and I'm not trying to confuse you by giving you alternatives in writing your answer. I'm just trying to get you to see that they are the same thing. Okay, so for our last problem here, this one's going to be a little bit of work, isn't it? So in this complicated formula, we are asked to solve for a, which is right here. What we need to do to solve for a is we need to start removing the things around the a, starting with the things on the outermost part of the formula first. So in other words, what I'm going to do here is just multiply both sides of this equation by 2. If I multiply by 2 on both sides, that's going to cancel the 2 here in the fraction. So let's give ourselves a little more room. And let's go through this very slowly. So multiplying both sides by 2 basically allows us to cancel the 2's here. And we end up getting on the left-hand side 2s, and on the right-hand side n times the quantity 2a plus n minus 1 times d. Now for the next step, we actually have a couple of different options. I could divide by this n, but if I do that, that's going to give us a fraction on the left-hand side, and we just got rid of the fraction. So I don't think I want to bring another fraction into this problem. Instead, I'm going to distribute the n here. And so that gives us 2s equals n times 2a, which is 2an, plus, and then n times n minus 1 times d. So still no fractions, that's good. And we got rid of one of our sets of parentheses. Now, don't lose sight of what you're trying to do. You're trying to solve for a. So my next step is, let's get rid of this term here that is separate from the a. And I can do that by subtracting n times n minus 1 times d from both sides. And that gives us 2s minus n times n minus 1 times d equals 2an. What's our last step here? Again, remember, we're solving for a. 2 and n are both multiplied to a. So all we need to do now is divide both sides by 2n. Doing that will cancel the 2's and cancel the n's, and will give us a equals 2s minus n times n minus 1 times d, all divided by 2n. And I know it's probably tempting, once again, to cancel these n's here, but please don't do that. You can't be selective in what you cancel. We'll talk more about canceling and simplifying fractions later on. Okay, that does it for these two sections. You're now ready to do some homework.